According to National Electrical Code Section 250.104, metallic piping systems that may become energized due to faults must be bonded together and connected to the grounding electrode system. This requirement applies to domestic drinking water piping systems, even when gasketed clamps are used to connect the pipe sections. The primary objective of bonding is to create a low impedance path for fault current, which helps to ensure the operation of overcurrent protective devices like circuit breakers or fuses. This, in turn, minimizes the risk of electrical shock and potential fire hazards. The gasketed clamps used to join the copper pipe sections need to be specifically listed for bonding purposes. This listing ensures that the clamps possess the electrical conductivity necessary to effectively maintain the continuity of the grounding path throughout the piping system. If the clamps are not listed for bonding, it's likely they do not provide a reliable electrical connection and additional bonding measures will be required. To properly bond the piping system, firstly, install a bonding jumper typically made of copper wire between each gasketed clamp and the grounding electrode system. Secondly, the bonding jumper size must be determined in accordance with National Electrical Code Table 250.122. This table provides guidance on the appropriate size of the bonding jumper based on the size of the overcurrent protective device protecting the circuit that could potentially energize the piping system. For example, if the circuit is protected by a 20 amp circuit breaker, Table 250.122 would specify the minimum size of the copper bonding jumper required. Thirdly, ensure that the bonding jumper is securely attached to both the clamp and the grounding electrode system. The connection points must be clean and free of corrosion to ensure a good electrical connection. Approved bonding connectors or lugs should be used to make these connections. These connectors are designed to maintain a secure and reliable connection over time. If the gasketed clamps are not listed for bonding, alternative bonding methods will be necessary. One approach is to install separate bonding jumpers directly between the copper pipe sections on either side of the clamp. This creates a bypass around the non-conductive clamp, ensuring electrical continuity. These bonding jumpers should also be sized according to Table 250.122 and securely connected to the pipe using appropriate bonding connectors. It is important to avoid running the bonding jumper through walls or concealed spaces unless it is protected within a conduit or raceway. This provides physical protection for the conductor and prevents it from being damaged or accidentally disconnected. Conduit or raceway also helps to prevent the spread of fire in the event of an electrical fault. Regular inspections and maintenance of the bonding system are essential to ensure its continued effectiveness. These inspections should include checking the tightness of connections, looking for signs of corrosion, and verifying the integrity of the bonding jumpers. If any issues are identified, they should be promptly addressed to maintain the safety and reliability of the electrical system. The grounding electrode system to which the bonding jumpers are connected typically consists of one or more grounding electrodes, such as a ground rod, a metal and groundwater pipe, or a concrete encased electrode. The grounding electrode system must be properly installed and maintained to provide a lower impedance path to ground. The specific requirements for grounding electrode systems are outlined in National Electrical Code Article 250. The purpose of bonding metallic water piping systems is to minimize the potential difference between the piping and other grounded metal parts in the building. This reduces the risk of electric shock if a person comes into contact with both the piping and another grounded surface. Bonding also helps to prevent the build-up of static electricity on the piping system, which can be a fire hazard in some environments. In addition to bonding the water piping system, it is also important to bond other metallic piping systems in the building, such as gas piping and heating ducts. This ensures that all metallic components are at the same electrical potential, reducing the risk of electrical shock and fire. When selecting bonding jumpers and connectors, it is important to choose materials that are compatible with the metals being joined. For example, copper bonding jumpers should be used with copper piping to avoid galvanic corrosion. Galvanic corrosion can occur when dissimilar metals are in contact in the presence of an electrolyte, such as water, leading to the deterioration of the connection. The National Electrical Code provides detailed requirements for the installation and bonding of electrical systems. It is important to consult the latest edition of the code and follow all applicable requirements to ensure the safety and compliance of the installation. Furthermore, local codes and regulations may have additional requirements that must be followed. It's crucial to check with the local authority having jurisdiction to determine any specific requirements for bonding and grounding in the area. Proper bonding of metallic piping systems is a critical safety measure that helps to protect people and property from electrical hazards. By following the requirements of the National Electrical Code and best practices for electrical installation, you can ensure that your domestic drinking water piping system is properly bonded and meets safety standards. The size of the bonding jumper is crucial to its effectiveness. Table 250.122 of the National Electrical Code dictates the minimum size of the bonding jumper based on the rating of the overcurrent device protecting the circuit that could energize the metallic piping. For instance, if the circuit breaker is rated at 30 amps, Table 250.122 will specify the minimum size of the copper or aluminum bonding jumper. Using a jumper smaller than specified could result in inadequate fault current carrying capacity, potentially delaying the tripping of the overcurrent device and increasing the risk of electrical shock or fire. The grounding electrode system is the foundation of the entire bonding and grounding network. It provides a low impedance path to earth, allowing fault current to safely dissipate. Common grounding electrodes include metal underground water pipes, ground rods, and concrete encased electrodes. The National Electrical Code outlines specific requirements for the installation and connection of grounding electrodes, ensuring they provide a reliable and effective path to ground. The connection of the bonding jumper to the grounding electrode system must be made with approved methods and connectors. These connectors are designed to withstand the corrosive effects of the environment and maintain a low resistance connection over time. The connection should be accessible for inspection and maintenance, allowing for periodic verification of its integrity. It is essential to avoid creating ground loops when bonding metallic piping systems. A ground loop occurs when there are multiple paths for ground current to flow, which can result in unwanted current circulating through the piping system. This circulating current can cause noise and interference in sensitive electronic equipment and may also increase the risk of electrical shock. To avoid ground loops, it is important to ensure that there is only one main bonding jumper connecting the piping system to the grounding electrode system. All other bonding connections should be made to this main bonding jumper. Regular inspections of the bonding system are crucial to identify and address any potential problems. These inspections should include visual examination of the bonding jumpers and connectors for signs of corrosion, damage, or loose connections. The resistance of the bonding connection should also be measured to verify that they are providing a low impedance path for fault current. Any deficiencies identified during the inspection should be promptly corrected to maintain the effectiveness of the bonding system. In addition to the requirements of the National Electrical Code, local codes and regulations may also have specific requirements for bonding and grounding. It is important to consult with the local authority having jurisdiction to determine any additional requirements that may apply in your area. Proper bonding of metallic piping systems is a critical aspect of electrical safety. By following the requirements of the National Electrical Code, best practices for electrical installation, and local codes and regulations, you can ensure that your domestic drinking water piping system is properly bonded and meets safety standards. This will help to protect people and property from electrical hazards and ensure the safe and reliable operation of the electrical system. The phrase listed for bonding on gasketed clamps indicates that the product has been evaluated and certified by a recognized testing laboratory to meet specific performance standards for electrical conductivity and mechanical strength. This listing provides assurance that the clamp is suitable for use in bonding applications and will provide a reliable electrical connection. When selecting gasketed clamps for use in a domestic drinking water piping system, it is important to choose clamps that are specifically listed for bonding. This will help to ensure that the piping system is properly bonded and meets the requirements of the National Electrical Code. If clamps are not listed for bonding, it is unlikely that they will provide a reliable electrical connection. The grounding electrode conductor connects the grounding electrode to the electrical service equipment, such as the service panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The National Electrical Code provides a table 250.104, that specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor must be securely connected to both the grounding electrode and the service equipment using approved methods and connectors. The connection to the grounding electrode should be made as close as possible to the earth. The connection to the service equipment should be made at the neutral bus or ground bus. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent protective devices will operate quickly to clear fault. The equipment grounding conductor is typically a green insulated wire or a bare copper wire. It runs along with the circuit conductors and is connected to the metal enclosures of electrical equipment such as junction boxes, outlet boxes, and appliances. The size of the equipment grounding conductor is determined by the size of the circuit conductors. The National Electrical Code provides a table 250.122, that specifies the minimum size of the equipment grounding conductor based on the size of the circuit conductors. The equipment grounding conductor must be securely connected to the metal enclosures of electrical equipment using approved methods and connectors. The connections must be made in a way that ensures good electrical contact and prevents corrosion. In addition to the equipment grounding conductor, metal raceways, such as conduit and electrical metallic tubing, also serve as equipment grounding conductors. These raceways must be properly installed and connected to provide a continuous ground path. The connections between raceway sections must be made with listed fittings that are designed to provide a good electrical connection. The bonding of metallic piping systems is an important part of the overall grounding and bonding system. It helps to ensure that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. Bonding also helps to minimize electrical noise and interference. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. It is important to consult the latest edition of the code and follow all applicable requirements to ensure the safety and compliance of the installation. Local codes and regulations may also have additional requirements that must be followed. It is important to check with the local authority having jurisdiction to determine any specific requirements for grounding and bonding in the area. The size of the bonding jumper is crucial for its effectiveness in carrying fault current. The bonding jumper must be sized according to Table 250.122 of the National Electrical Code, which specifies the minimum size of the bonding jumper based on the rating of the overcurrent device protecting the circuit that could energize the metallic piping. Using a bonding jumper that is too small can result in inadequate fault current carrying capacity, potentially delaying the tripping of the overcurrent device and increasing the risk of electrical shock or fire. The material of the bonding jumper is also important. Copper is the most commonly used material for bonding jumpers because it has excellent conductivity and is resistant to corrosion. However, aluminum bonding jumpers are also permitted in some cases. If aluminum bonding jumpers are used, they must be sized according to Table 250.122 and must be installed with listed connectors that are suitable for use with aluminum. The connections of the bonding jumper must be made with approved methods and connectors. The connections must be clean and free of corrosion to ensure a good electrical connection. The connectors must be listed for the application and must be properly installed according to the manufacturer's instructions. The bonding jumper should be installed in a way that protects it from physical damage. The bonding jumper should not be run through walls or concealed spaces unless it is protected in a conduit or raceway. The bonding jumper should also be protected from mechanical damage, such as being crushed or cut. Regular inspections of the bonding system are essential to ensure its continued effectiveness. The inspections should include visual examination of the bonding jumpers and connectors for signs of corrosion, damage, or loose connections. The resistance of the bonding connections should also be measured to verify that they are providing a low impedance path for fault current. Any deficiencies identified during the inspection should be promptly corrected to maintain the effectiveness of the bonding system. In addition to the requirements of the National Electrical Code, There may be other industry standards and best practices that should be followed when bonding metallic piping systems. These standards and best practices can provide additional guidance on how to properly bond metallic piping systems and ensure their safety and reliability. The proper bonding of metallic piping systems is a critical aspect of electrical safety. By following the requirements of the National Electrical Code, industry standards, and best practices, you can ensure that your domestic drinking water piping system is properly bonded and meets safety standards. This will help to protect people and property from electrical hazards and ensure the safe and reliable operation of the electrical system. The location of the bonding connection is also important. The bonding connection should be made as close as possible to the point where the metallic piping enters the building. This will help to ensure that the entire piping system is effectively bonded. The bonding connection should also be made in a location that is accessible for inspection and maintenance. The bonding connection should not be concealed behind walls or ceilings. The type of grounding electrode system used will also affect the bonding requirements. If the building has a metal underground water pipe that is used as a grounding electrode, the bonding connection to the water pipe must be made within 5 feet of the point where the water pipe enters the building. If the building has a concrete encased electrode, the bonding connection to the concrete encased electrode must be made at the point where the reinforcing steel is exposed. If the building has a ground rod, the bonding connection to the ground rod must be made at the top of the ground rod. The number of bonding connections required will also depend on the size and complexity of the metallic piping system. For large or complex piping systems, multiple bonding connections may be required to ensure that the entire system is effectively bonded. The National Electrical Code provides guidance on the number and location of bonding connections for different types of metallic piping systems. The use of thread compounds on threaded connections can also affect the bonding requirements. Some thread compounds are conductive and can provide a good electrical connection between the threaded parts. However, other thread compounds are non-conductive and can prevent a good electrical connection. If a non-conductive thread compound is used, a bonding jumper may be required to ensure that the threaded connection is properly bonded. The use of dielectric unions can also affect the bonding requirements. Dielectric unions are used to prevent galvanic corrosion between dissimilar metals. However, dielectric unions also interrupt the electrical continuity of the piping system. If a dielectric union is used, a bonding jumper must be installed to bypass the dielectric union and maintain the electrical continuity of the piping system. The bonding of metallic gas piping systems is also important for safety. Metallic gas piping systems can become energized due to faults in electrical equipment. If a person comes into contact with an energized gas pipe, they could receive an electric shock. The National Electrical Code requires that metallic gas piping systems be bonded to the grounding electrode system. The bonding connection to the gas pipe must be made as close as possible to the point where the gas pipe enters the building. The bonding connection must be made with a bonding jumper that is sized according to Table 250.122 of the National Electrical Code. The bonding of other metallic systems, such as heating ducts and cable trays, is also important for safety. These systems can also become energized due to faults in electrical equipment. The National Electrical Code requires that these systems be bonded to the grounding electrode system. The bonding connections must be made in accordance with the requirements of the National Electrical Code. The importance of proper bonding cannot be overstated. Proper bonding is essential for protecting people and property from electrical hazards. Proper bonding also helps to ensure the safe and reliable operation of electrical equipment. If you have any questions about bonding requirements, you should consult with a qualified electrician or electrical engineer. They can help you to determine the specific bonding requirements for your situation and ensure that your electrical system is properly bonded.